Hello everyone, this is a video on simplifying radical expressions, and we're going to start with the rules. Now there's a rule for adding and there's a rule for multiplying. First of all, in order to add radicals together, you must have exactly the same radicand, and what I mean by a radicand is the number underneath the radical. So for example, you could add 3 square roots of 5 plus 4 square roots of 5 together, and you will get 7 of those square roots of 5. Okay, that's perfectly fine. What you can't do is add the two together when they don't have the same radicand. For example, right here, the square root of 9, of course, is 3. The square root of 16 is 4. So this actually gives us 7 as an answer. If I were to attempt to add the square root of 9 plus the square root of 16 and try to do 9 plus 16, which is 25, should have made that a little longer. Obviously the square root of 25 is 5, which is not 7, so you cannot add them whenever they're not alike. So the number underneath the radical has to be the same. However, when it comes to multiplying, you can multiply them. So for example, square root of 9 times square root of 16 gives us 12, and if we were to multiply 9 times 16, if you get your calculators out, 9 times 16 is the 144, and lo and behold, square root of 144, 12. So it does work. That's okay. Alright, so adding and multiplying, two different things. And by the way, the same thing is true of subtraction and division. Division is okay, subtraction is not, unless they have the same radicands. So here are a couple of simplification examples. When it comes to actually simplifying radicals, my favorite way, and there's lots and lots of different ways, there's factor trees and all kinds of things, but my personal favorite is to make use of your knowledge of perfect squares. And in this case, what you want to do is look for the largest perfect square number that'll go into 50 evenly. And in this case, the perfect square that works is 25. So let's break it down to 25 square root of 25 times square root of 2. Remember that it does work to multiply the radicands. Okay, so multiplication is fine. This is a perfect square, so then simplified, this becomes 5 square root of 2. Now if you're not sure what I mean by perfect squares, send me an email. I'm happy to explain. Now if there's a number in the front, you're still going to do exactly the same process. However, this is multiplication right here, so this is going to be 7 times 5 square root of 2, okay, which is what the square root of 50 right here became, and so these two numbers out in front will multiply and become 35 square root of 2. Okay. Now, continuing just in another complete example, you might want to pause at this point and see if you can do this without working it out. So pause here and see if you can do it, and come back. So we did the square root of 50 a moment ago. So this is 3 times 5 square root of 2. Okay, but we haven't done this one, the square root of 28. So what's the largest perfect square that goes into 28 evenly? And that's 4. 4 times 7. Okay, minus 11 times, what's the largest perfect square that goes into 32? The biggest one is 16. Okay, and I'm going to come back and talk about this one in a moment, because you may not have picked 16, you might have picked 4, and we'll come back to that. So this first term right here becomes 15 square root of 2 plus, and here we're going to have 2 times square root of 4 is another 2 times square root of 7. My handwriting is horrible, so bear with me. Minus 11 times 4 times square root of 2 again. So then we have 15 square root of 2 for one term. We have 4 square root of 7 for a middle term, and 44 negative times the square root of 2 for the third term. And we have two like terms right here. So 15 and a negative 44 is negative 19 square root of 2 plus 4 square root of 7. Now this is about as complicated one as you could possibly get, and we probably, in all honesty, won't see anything quite this complicated in Math 130. But I will tell you this, if you can make it through every single one of these steps, then anything we come to in college algebra, you'll be able to handle just fine. Now, I want to comment on the square root of 32. If, for instance, you did not pick up on 16 being the largest perfect square, maybe your first instinct was to go with 4 times 8. Okay? You want to pick perfect squares though, so, don't go choosing, like for example on number 28, or with the square root of 28, you could have picked 2 times 14 because that's 28, but the problem is neither 2 nor 14 are perfect squares, so that's not helpful in being able to simplify and lower the number underneath the radical. So over here, sorry, I got sidetracked, the square root of 32 could break down to square root of 4 times square root of 8. So 4 is a perfect square. That would give us 2 times the square root of 8. The problem is that 8 can also be reduced further because another perfect square goes into 8. So you would just have another step to go through because 4 goes into that again. And so we wind up with all these 2's running around, square root of 2, which of course gets us exactly the same thing we had way back over here. Okay? Oops, sorry, I was pointing to the wrong one. 4 square root of 2. They are exactly the same, okay, in either method. If you have any questions about simplifying, let me know.